Good morning. Good morning, everybody. Good morning. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, January 27, 2022, Thursday. It's 3:25 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक 27 जनवरी 2022 बृहस्पतिवार सुबह के 3:26 आपके सामने हाजिर। And talk is about quality as usual. Continuation of quality talk, quality works. Title is as indicated here. Quality works, concrete specifications, field engineering, civil field engineering, life engineers, AnnexSL, Red, Silver, White Books, SHE, Designs Construction, Methods, Contracts, Disputes, Organizations, Communications, Coordinations, Why, Quality of Materials. You can see my email ID here. This is for information. So I have not received any message, but here is my, you can say, identification board. You may call it my name board. It's already fixed on my door. And this is Suraj_engineer at yahoo.co.uk. Ireland ID, no problem, but I am in Bharat, India. By chance, when I first time tried for ID, so I got this. I didn't know at that time. Well, no problem, it's only message. You can see, you can again say Suraj, SURAJ _engineer, ENGI and ER, and you know all that. Telephone number is also there, address is there, but please don't call me because I prefer detailed writing. I want to see your writing. If you can send to me some questions, some clarification or something else, or how do you think or what do you think about this talk? You like it or you get some benefit or no, or it's just waste of time, or I'm trying to befool myself, or means you can say that openly. There's no issue. You may be young, you may be old, you may be senior, you may be veteran, whatever you are. And my certification, third certification of International Professional Engineer India. Third it is. First was taken in 2012, second was 15, and then third is 20, and that is on 30th September 2020 it was approved, and it's valid up to 30th September 2025. You may say this is a rule, this is law of this certification. Validity only for 5 years, and this is beauty of such certification, and it's all over world like that. It's not continuous one, it's not permanent ones. Every 5 years you have to prove that you have achieved something, you have updated your knowledge, and you have also updated knowledge of others in profession as well as otherwise. That's why only 5 years is allowed for this certificate as well as for professional engineer certificate. Chartered engineer certificate is not broken, it continues until one is corporate member of institution. Selection process for both is difficult, not easy. Selection process for international professional engineer, that one has to appear in examinations, written examinations, 2 papers. First you have to pass first one, then second one, and after passing both you have to appear in an interview, online or you can say video conferencing interview. And once you qualify all these, then only you are considered for recommendations by Board of Certification of Institution of Engineers India Bharat, and Institution of Engineers India Bharat is official representing body of India on International Professional Engineers Agreement body. That's what's for information. And this Chartered Engineer certificate is issued per Charter, Institution of Engineers Charter 1935, which permits corporate members to be authorized or to use style and title Chartered Engineer India according to our constitution and statutes approvals. And this is fellow membership, one of three grades of membership. Top is fellow, then it is member down, and if you go further down, it is associate member, which is start one. You can say associate member is corporate membership one, then second one higher is member, and third is fellow. And here is my quality file. I close the C file and I close FI file, and I am here on quality file. We discussed yesterday at length, but there is no end to this kind of file, because this reminds me every day. This reminds me and I remind you. And reminding objective is very important, because engineer means quality personnel. Try to understand my point. When particularly I say engineers, this means a person with quality. Otherwise, there does not exist any meaning to be called or to be named engineer. If a doctor, we call medical doctor, who is also a person of high quality. If doctor cannot think of health of people, or doctor doesn't think that medical service is service or it's a business, one of two. When one doctor enters into business, in that case I cannot comment. But when doctor serves as a professional, it's patients, in that case I can say it's quality doctor. Quality means highest character in profession. When I say quality engineer, it means highest profession, highest professional in engineering. Quality is a term applied generally all over the world, and character is term just we can say at personal level. After all, every professional is personal first and then professional later on. So what is position of your being personal is very much important, or you can say it can be used as measurement of your capability. Measurement of everybody's capability. First I know what is my capability, and I try to use that capability for purpose in profession. And depending on my performance of work, whatever I can do, others can measure what is my status of knowledge, what is my status of performance, how do I perform. They can come to know once they observe me for some time, for some duration. Engineering is not personalized, but performance is personalized. Every person is different, every engineer is different. Different in a sense that personal involvement is significant. Just looking at certain certificates of academics, we can have some information about person, that at least this person know this much, at least. Extensively there is no limit, but minimum we can say if this person is a bachelor or it's a diploma or it's master or doctor, whatever, this person at least know this much. Otherwise there is no meaning of that certificate. Certificate gives that certain standard this person is having. Same way, professional certification. Look, academical degree is not a professional certification, that is educational certification, that this person has been educated in engineering or medical sciences, and that person can work. But when you come to different certificates, we can call professional certification, or we call it competency certification. Competency is more weighable, because competency means this person has some legal capacity to work. Legal capacity means this person is socially trusted by law. Law has entrusted this person to serve, and that's why there's a difference. So when I say competency, it is something acceptable, something recognized by law. May not be mandatory, but recognized by law, and that's enough. When a person is recognized by law, means recognized by public. Law means public. Public can, just after reference to that certification, trust that person. Even not only means I not necessarily say that you demand that certificate, it's not essential. Even a statement by someone that I have this capacity, I have this qualification, it's enough. Because at higher level, when you are engineer or doctor, personal character is very important. As I said, quality person. If I do my work and I declare that I am this one, it should be trusted. After all, responsibility is a degree there. I have a responsibility towards society, and society has also a desire for its professional to do something for its development. That's why I say when you talk of profession, profession is not easy first of all for everybody. And profession is not something that we can link it to money earning capacity. Those who link profession to money earning capacity, those are only commercial based people, business based people, they don't respect profession. Those who respect profession, they never link it to money. Because every act cannot be linked to money. When you think something about professional activity, it doesn't link to money, it links to fulfill requirement. To fulfill requirement of that activity, smooth functioning, that is what is required. Every act cannot be linked to money, but it is unfortunate that current situation suggests that people are more and more interested in making money rather than doing something practical for development. Every profession, when you say, has become so polluted now that when you start your education in that profession, you have an intention to get admission into whatever course after passing your schools. Everybody measures what shall be packaged after passing this course, passing this program. And that is really unfortunate, I can say, that you are inclined to money earning capacity even when you think of doing some work or some academic admission. And that is where quality drops in itself at beginning. You see, we have to think of development of world, development of our country, development of mind and our strength in intellectualism. Engineering, medical science, at least these two can be called original intellectualism areas of education or world. There are other professions also, they require intellectualism, but these two professions are different because both these are originally motivated professions, originally designed. Without medical assistance, life becomes very difficult. Same way, without engineering development, life becomes very uncomfortable. But other professions, you can say, for example, law, or you may say chartered accountancy, or whatever else, arts or science, those are not directly related to people in that case. Medical science is related to people, individual as well as society, and engineering is related to each and everyone, not only in this country but also all over the world, and both professions are therefore very significant in that case. So we can say quality when we talk of, it's not simple quality as you think it is, this and this and that. No, that is one part of quality. Quality means we have to think of individual, and that is very important part because it may be medical science, it may be engineering science, or it may be other areas. Sorry, it is individual who is involved in all activities, and quality depends on individual's quality, individual's performance. Individual means professional individual, not every individual. And when professional engineer has certain quality, certain capability, certain consistency in doing whatever work, whatever activity, it impacts everybody because doctor when treats someone with full confidence or full dedication, it impacts its own personal, nurses, compounders and others, as well as it impacts patients also. So you can say doctor sends some integrity to society, that medical is something reliable, trustworthy. And same way if engineer does some work on similar pattern, it sends a message to the whole society because of engineer deals with workers, that he utilizes workers and machines, all resources, and those workers know that this engineer is very good, this engineer cares for work, and this engineer does according to sincerity requirement and follows the specifications or quality system. So it changes mindset of everyone. Suppose an engineer uses 100%, engineers acts through its own personal impacts 100 workers. You can then think these 100 workers send message to its families. So one act, one performance, one performance criteria by engineer goes to how many people? That's what I'm saying. Multiplication of application of individual character changes entire scenario. We have to get this point into understanding. Means indirectly we teach others. Indirectly professionals teach others, though it may not be formal teaching but actual teaching. We force indirectly, or we you can say enthusiasts, we can say we try to send messages or pass messages to our juniors that you have to take care of this activity in a proper manner because I am taking. For example, if I am a leader, I go to site or go to office in time, and others to go with this. Our senior has come in time. Certainly, they would come in time. So it is sometimes self-declaration lead that sends a message more importantly, more significantly than explaining to someone, instructing someone, you do this. You demonstrated yourself first, and that's why I call senior people have more responsibility, first level responsibility of being responsible, obliged, and be regular, punctual, and committed. If one is that, if one person is that, it impacts everybody else. Maybe some people are bad there, you cannot change them, but in 95 to 98% cases, those who aspire looking at their seniors, that senior is like all these gentlemen, this senior portion my boss is itself regularized, self-regularized, self-disciplined. So we have also to be self-disciplined, and that's why you see those who lead themselves very well. They always have excellent teams with them, committed team, dedicated team, and that's what is required. So I, in beginning of this talk, said that individuality is very important to be understood. No individuality means there is no meaning of group. If individuals are not trustworthy, you cannot constitute any trustworthy group. And you know, we always compare to each other. We always, when we sit together, we pass comments about others. This happens. So maybe people sometimes tease indirectly. This man thinks very nice to he only thinks he is sincere. But that may be temporarily talk by what say. They have to follow you. If someone doesn't want to work sincerely, that may pass some remark. Doesn't matter how long, how many times. Because when you are dedicated to work, you are dedicated to system and quality and system. You make yourself if you can't follow system of others. Because when you are a regular person, when you are a committed person, you care about system, you care about quality. Certainly, you constitute a system, though it may not be formal. But people know what time this guy comes, this guy goes, how he thinks, how many times, what's his frequency of talking, and how does he talk? Does he talk unnecessarily or talks to points? Or that person just does all time something to demonstrate to others, see, I'm doing this, you are doing that, and you know, gossipism is not believed there, work is believed. So you can see you can build yourself what you want to show to others, and that's why I say quality is related to individual work, and your personal quality is very important. You may call it personal quality, or you may call it personal character, or whatever you can say. Quality and character are not different. If you're a characterized person, you're a quality person, first of all, you have to measure yourself, your achievements. You know what you are, but you have to explain to others what I am, because you cannot self-praise. Demonstration gives indication your work quality, work system, your work standards tell others what you are. That's what's required, and that's where quality plays an important role. Every individual is very important in quality system. We talk a lot in quality system, and I have been talking always quality system, but that's not something you take as a framework or something. It's not that, but it's just activity of individual. In fact, we say, how does one perform? How does one team perform? It's that one. It may be ISO 9000, it may be Sigma, some whatever else means. There is no material use in that. Material is information. Material is what thing. So only thing we write that. So it is in fact individual performance dominating system. And when there's only one individual somewhere, means okay, it's fine, but it rarely happens that there is one in some organization. Organization means at least 2 or 3% must be there. Only then we can call ourselves okay. One must organization means it's not that powerful, but yet organization. There's a difference. It's organized team and manageable team both have different. When I say organization, it means really something organic. Organs are there, many organs are there. Organization, it has some, you can say, level of different areas, and they can think differently. That's why I say we have to organize, we have to institutionalize, you can say rather, organization. We have to institutionalize ourselves. And that's why title about quality is sometimes very different. Same title remains, but meaning changes. So yesterday also I said, today also I'm saying, get up and don't stop. Don't sleep, get up. You have to move. Long way to go. It's not imaginary talk, it's talk in profession. Profession demands all these. Profession, because itself is based on advanced knowledge, advanced attainment, advanced journey. It also requires you to move together. It's like a train journey, which takes sometimes 2 or 3 days to reach some destination. And there reach so many stations in between where it stops and returns. Same way we can say quality is a travel, or you can say it's a train journey. You have to travel, and from one station to other we have to move. And ultimately, a destination access where we have to reach that goal, that target, that our, you can say, destiny, fate, aim, we have to go to. That's the reason I'm talking about quality, and quality is that destination. Defined quality is not natural quality. We ourselves define something and work on that. So we can limit something from this limit to that limit. Is this work to be done? This is minimum requirement and this is maximum requirement. It's said like that. In this range to that range, that is what it should be. That's just like on many test reports, when you see so many parameters are given. And according to the requirement, this should be parameter, and according to test, this is parameter. If tested parameter, tested quantity lies between that range, which is requirement of code, it's called, okay, fine, it's acceptable. And if it's below that, it's not acceptable. And that's what we say, range of quality. We have many ranges of quality in every activity. And out of those ranges, we have to fix our range. This is our target. We should not go below this. We can be above that, but not below that. Sometimes, it's important to understand this point. So I'm not saying that we can just cry and shout to get quality. Shouting or crying does not get you quality. It does not help. In engineering, it requires you have to shout many times, you have to cry many times. You have no right to cry if your information which you expected to be used does not reach those who work on that item. Information is very important. Information, what it is? Information is available in abundance on internet. But whether or not related information that you looked at or found is really right, that's what I'm saying. So it is better to ensure once whatever information you have, that is per requirement or that is per definition of some project, and that information is very healthy if you are right. because availability of information means availability of a speedy performance. Whatever information you have, if you is utilized, it gives better results. Rather than assuming or presuming means I take this condition and then apply this. So subject to this condition, this problem is solved. It's not like that. That's why I say get up quality. I'm asking quality. Get up, you guy. I'm not asking you. I'm asking quality. Get up. You are sleeping. Don't sleep. Actually, here sleeping doesn't mean which physically sleep. This means ignoring, or this means avoiding something which should not be avoided. We have habit that we want to bypass if we can do something, just like it happens in examination paper. You have got a paper, it's 3 hours or 4, whatever number of hours. You have to do 5 questions out of this one. So you select all questions, you read all questions, you find best one that we can answer immediately. You don't say, no, first I have to do first one, then second one. In sequence I have to go. To go in sequence is only possible when you have thoroughly studied that subject, and you know every part of that subject. Only then you can go through that. Well, I'm just, this is an example only. It's not reference. So when I'm saying get up quality, stop sleeping. Well, it's very one phrase, get up and start and stop sleeping. It's only small phrasing, but it's got a lot meaning. I say get up quality. I'm asking myself, someone else, get up guy. To get up quality. First of all, you have to get up yourself, because your quality is also in question. Your own quality, my own quality. When I say get up quality, I ask myself and I ask my others whom I instruct, get up gentlemen, do not sleep or stop sleeping. Usually the sleeping word is used in very advanced way all over the world. Particularly in those countries we just respect others. It doesn't mean you are sleeping by face or by physical mode. You're in bed, you're resting. It's not that sleep. It's sleep of conscience. It is sleep of mind. It's a sleep of attention. Means you are sleeping in attention. Your attention is not concentrating on required focus. It is elsewhere. So we say, come on, don't sleep from this. Stay here on this line. You are driving a train. Sit on here. Look at what's happening. Is someone there on track? Or means are signals on? And if you don't look at that, train may pass red signal, stop signal, and it may cause accidents or collision. Same as what I'm saying, get up quality, stop sleeping. Because I know quality I did not follow, but I say you get up means I awaken myself to get up. Everybody awakens itself. If I sleep, I can't know what's happening, I can't observe, I can't see. I have to see what's happening. And that's why I say stop sleeping. So my dear friends, you can use self-analysis, analyze yourself, what you want to think, what you want to do, what you want to plan, what you want to do. And do you want to check it or you don't want to check it? You have overconfidence in you. And if you want to improve it, you can improve it. So you say plan, do, check and act. Very, very simple principle it is, and it's not even indicative principle. You have not to tell someone, you have to plan something. Everybody knows planning is required. Planning is required each place in life. Even if you want to spend few hours somewhere, you have to plan for that, what you do. For every activity you plan something. And we have talked about engineering activity, it's big one, because your engineering activity shall change your life. Engineering activity also may vary, it depends on which product you are going to do. When our product is construction, our product is lifelong structures, that is not ordinary product. It's first of all cost, enjoying cost, expending. Without cost you can't get it, without price you cannot get it, without availability of material you cannot get it. Without technology, you cannot get it. Without equipment, you cannot get it. So when there are so many requirements in that work, what level of work it should be, how many quality factors are involved, what's procedure involved, we have to see all that. So I say, there is no question you sleep. You cannot sleep in all those contemplations. When you think about it, you think for every requirement. Do I have machine? Do I have workers? Do I have material in time? Do I have technology to do this? Do I care about delivering it, and after that will happen? All these are very important factors of quality. So we can just say, as I say on or write on this, have active quality performing application. You perform application, I know, everybody knows, and its work application means it is work application. It is also simultaneously called active quality application. Have active quality performing application, and that is added with quality of safety, health and environment. Whether you maintain safety or you do not maintain safety, that's also a part of quality of safety in itself. And safety doesn't mean that you have to show your dress. It means that you have to keep you safe and you have to keep others safe. And then of course we have to include in that engineering approach. It is safety engineering, it is health engineering, it's environment engineering, it's quality engineering, it's planning engineering, or whatever subjects we can say are included in branch of engineering. An engineering approach on working designs. Designs in engineering are very important in every branch of engineering, and we talk of civil engineering means its highest profile designs we have, because we have to contemplate on what we are going to do. Software came just before few decades, but before that also designs were done and very intellectually done. Long calculations, long activities, and then drawings itself manually. Those times were very busy, very active, and because these times people used to think using mind in most cases in drawing itself. It was brilliant period of profession. Now life has changed. Means we have started avoiding use of mind all time, and we have started depending on software and depending on drawing way. So you can say level of this reduction of level in intellectual status, everyone. And I think that's the only way where we have no pleasure in working, because our pleasure has been snatched from us by these softwares, by this rapid printing. There was time we used to draw ourselves. Now drawing is not that important as computer commands. So I say have active quality performing application is only answer. Quality in safety etc. is an answer. An engineering approach on working designs, and when I say working designs, it's very big issue. It's very big quantum. It's very big, you can say, quality question. Working designs. Look, when we design, we say we have to design this building, or we have to design this structure. Designing a structure is not simply using formula and thinking how to handle these forces, whatever compression, tension, moment, shear, or etc. that acted upon on this structure. It's not that simple answer. It's a big question that we have to understand what we are going to do. That is an important point. Means how shall we do it practically? Our details should be very simple, that a person on site knows or understand it by reading drawing itself what is to be done. Means working designs. maybe have systematic or schematic designs. Those designs must be converted to thorough, easy, convenient details, constructible, buildable details, and that buildability and constructability is directly linked to real design or detailed design. And these details must be very clear and explicit that person converting your design to physical mode can read them very well without any wasting time, without any mix up, without raising any further query. If we can achieve that level of working design, it must be really wonderful, because habits of drawing has gone, habit of writing has gone. We have become, slaves to computers. In fact, I should say, there's no question in this, no pinpointing in this. We have become computer slaves, generally all, and we think it's a privilege to use computers, but we are not using computers, we are being used by computers. This stage has turned otherwise. We don't realize that, but it's a fact. That vision power of mind has been reduced because it's not used. Calculation minds that used to do in past, those opportunities have been destroyed because we do not want to do anything manually. Everything should be done by computer. So you can say chances of repetition of your activities, chances of repetition of whatever you do are not manually done. And that means we do not respect our work. We feel some in guilt. Oh no, I did not do that. That person did that. It happens. So we have to see this very definitely, and we can say in our manufacturing, in our construction procedures, we have to think like that. Only we can go further, and that's the reason I always name this as fixed quality. Fixed quality in Bharat, India. And when this point is about India, Bharat, it's for this country, and also same can be fixed anywhere, everywhere in other parts of world. We have to fix it. This means there is some destabilization in quality system which we have to check, and we have to reach quality system only when we can handle quality in each element that is a part of that work or system. So we have to be very careful about this, and being very careful means we have to first respect quality. We have to first recognize it. Otherwise, it's not possible that we take care of this. Therefore, I try to explain as much as possible all the time with different considerations, and also now we go further on this. Same way, questions cannot be changed, can be redefined and redefined. I have not redefined again and again, but questions is still same. Work's quality cannot be compromised. That one point we have to keep in mind. Come what may, come what may, we have no right. We have no right. Because by engineering, we have no right by law. And of course, we have no right to, you can say, tease ourselves. If I do some work and this work is not done per requirement, I feel myself that I've done wrong. But yet we don't disseminate that, or we don't tell others. We leave it to them. But what I say, when we say work compromise quality is not acceptable. Work cannot be produced where quality is not allowed. Or we leave it to work itself. Let us see what happens. That stage is not acceptable. We have to be very sure that work quality work quality cannot be compromised, because we say I'm not responsible for output, but I'm responsible for compliance of quality system. We can just, you can say, have some shelter. For time being, that shelter, you may say, I got this shelter outside. Getting shelter outside doesn't mean your solution. How to shelter your work, how to keep safe your activity without questioning from any other corner. And then you can say it gives an impetus to self-confidence. This person has done it, and this person says that this is all right. So we can say we should think system later on. We have to be very careful about quality that cannot be allowed to be compromised by anyone. If we follow that mode, we use secondary power to system, first power to quality. In activity, quality in, you can say, testing, in checking, quality controls rather, you can say. If we change to previous status, the quality control is first requirement. Quality system then becomes automatic movement. All your activities, whatever you do, those need not be synthesized, but those those tell us what is quality. When consumer gets product, consumer knows it's good product or bad product. It's not logical to say that system is accepted, system works means quality works. This is not acceptable because it is not robot work, it is work by humans, and humans are not fixed in quality. Sometimes you have very good team of some activity of workers, and workers activity or construction activity, and your team is good one, sincere one. In that case, your own headache also is down. But if you teach everything to others, how you have to do this, if you discipline in that way, then you have to do, of course, lot work every day. But in a couple of days, people know what this engineer wants us to do. If first time, second time, at 10 levels, no, we know this, we can do that one. So I say in quality system, fragility, we should not compromise. That's what I'm saying. And we should not think that formality shall save us. Formality shall help us. That's not absolute answer. Because ultimately we have to help ourselves. And that is also a fact in life. We have to help ourselves to survive. How to do that? And that's the work of national leaders. But otherwise, in technical way, in professional way, it's engineer leader who has to do, who has to lead self. So quality system is not mandatory if your quality control is not effective. You cannot run your quality system. Quality system can be run only when individual is perfect, individually dedicated, committed, sincere. Otherwise, there exists no meaning of quality system if quality control is defective. System in system devised by many people, many experts, but you cannot say that every expert is expert in everything. I'm not worried about if system fails, because if system fails, we know where is the problem, where does problem exist. This failure system shall declare itself. Yes, I am failed. There is no answer on this question. My support doesn't work. This is why I'm trying to analyze what we say, and it's performance, and it's really very important one when we say what we say here in various questions, that as if the red lines I name it because quality is bad, It's in function to its real requirement. In that case, can we know? Can we know? My question is, for those works which I did abroad, or you do overseas other than our country, and when you say how we had to approach their respective quality functioning, and when we talk here nobody you can say looks in that direction. We are good people in hiding or in tolerating everything. Suppose somebody calls something on my activity, the work is not reliable. It will pinch me, but I would simply say, you go and learn yourself, and then you do it yourself. With no facts. My dear, it's very different question and answering talk. I'm questioning myself and answering myself. But you have a right to raise question. What I say here, can we know and apply quality standards complied with overseas, for example, in GCC countries on buildings and on plants facilities? Well, I am just conferring on this subject. There is reason that I have seen many countries workings. Maybe now how they work I do not know. But during my time I enjoyed those activities, and I also realized that of course we are not permanent here. Nobody can say we are permanent here. We may be there for a couple of years, couple of decades, but ultimately we have to go back our unknown home, ourselves unknown home. That's why quality is a question mark. We cannot just throw it away by thinking that quality doesn't mean anything. As far as concrete is concerned, you may say that I have a file here which I have referred to you, and this is not my file. This is official file of American Concrete Institution. The various terminologies are involved in this, and these terminologies, if you know in concrete, there may be terminologies in other subjects. This terminology is very important for every engineer to know, understand, and we may have our own terminologies also. When engineering, own or not own is not issue. Engineering is worldwide same. Maybe it takes some time to move from one end to another end, perpetual rotation of Earth, but otherwise time is required for every activity, and if we do not have any degree of seriousness, time shall also not be with us. So I say concrete terminology we discussed. It's very primitive of course, but it's very important what we discussed in this. We can say, if you see, it is, all this. I'm not interested in interview, I'm sorry. And now, there's a terminology here, for example, we study, I'm just trying to repeat that, not to explain them, but for example, we say A to Z, this alphabetical words used in terms of concrete, and this is actually a platform where we can say we know what is American Concrete Institute terminology list, and whatever it is, but for example, it's AF ratio, and then this Abraham's law. I'm not going to tell each and every what's that. I'm just going to share with you. I have discussed all this. And abrasion, damage, abrasion resistance, absolute volume, absorbed moisture, absorption, abatement, accelerating admixture, acceleration, accelerator, accidental air, that is entrapped air, and acid etching, and then it is acrylic resin, active crack addition, and then addition, adhesive, adiabatic, admixture, adsorb water. If you Its molar or mass ratio of aluminum oxide Al2O3 to iron oxide Fe2O3 as in Portland cement. We have Abraham's law, which says a law ruling or rule stating that we are given concrete materials and conditions of test, ratio of amount of water to amount of cement in mixture determines the strength of concrete provided for its current. Same way you can say, as I say, prime law, when there is abrasion damage, wearing away of surface by rubbing and friction, and there is also abrasion resistance, ability of a surface to resist, being worn away by rubbing and friction. There is absolute volume in case of solids, displacement volume of particles in the case of solids, displacement volume of particles themselves, including their permeable and impermeable voids, but excluding space between particles. In case of fluids, the volume. Likewise, various definitions and terminologies are given, which we have gone through, and this can be continued later on also. I was trying to refresh what we have done. It's also long list, it's not just completion or end of this, and also we discussed about another file, and that is you can say here it's a research note here, and that was incredibly discussed. It was not fully discussed because it's regarding quality of concrete, and we had a chance to this somewhere else. I think we are somewhere else in this. Yes, we are somewhere here, I'm sure. It was continuing service of NPPS, continuing service of NPPS. So, degradation considerations, I think it's somewhere here, degradation consideration, let's say what it was. Thus, whether a concrete structure degrade is a function of many factors. Let me switch off my battery so that this works safe, and then I'll listen up, please. Cold, really, very cold. I did not show you temperature, but temperature is, and it is normally not very good. It's really, if I see temperature now, it is difficult to digest for me. Maybe for you, no, but for me it is difficult to digest. And 5 degrees, oh my god. Real feel too, I'll show you. It's really very important here. If I know this, it's very important, You can see that it's 5 degrees, and I print it for you. It was now I'm getting colder and colder, and the reason being this, I'll show you this. Now it is about it's 4:21 morning. It's 4:21 a.m. and you can see this PDF file from accuweather.com. Its format's freezing, you may say. You can see this file. It's Thursday, 27 January. Current weather is 5 degrees and real feel is 2 degrees. You see this one. Real feel is 2 degrees. And it's Faridabad. So it is here. Wind, you can say wind is 13 km northwest. Gust is 22. Humidity is 75%. Indoor humidity 41%. Dew point is 1. So 12.2 kilometer is cloud ceiling. Visibility is okay. Expected time in day is 18 degrees stalling. And next is 6. So current is, at this moment I'm talking to you, it's 5 degrees Celsius and feeling is 2 degrees Celsius, and that's why I was a little uncomfortable here. And this is for 20 a.m. time, and I just said it's sometimes very difficult to get this. I just tried to show you because I can't link it to FP in this form. This printed page. I close it now and I close this. So we go through degradable considerations, and here we can say we have to find also concrete some information, concrete quality, which is really very important. Concrete quality. Let us say what somebody says. Concrete quality. What is that? How people think about concrete quality. It says simply that quality of concrete is affected by different physical and mechanical properties of aggregate, shape, grading, durability, specific gravity, and water absorption, etc. These properties are aggregated should be tested before using it for concrete production. And okay, I'm not going to very normal definition. This concrete quality, an overview, and this is by Science Direct Topics, evaluation of in situ concrete quality, uniformity, grade of deterioration. Strength becomes important when reinforced concrete structures present. So let us see what it says. I'm not sure, maybe something reliable. This concrete quality. It is 2016 paper. Let us see what it says. I just read first para. If I can get something, and that will download it. Otherwise, assessing a concrete's resistance to chloride ion ingress using formation factor. Well, I think this may be reasonably well. Let me download it if I think this can benefit me. Accessing a concrete's resistance to chloride ion ingressing using formation factors. Just a minute. Let us see if something comes out of this. No, it's only one paragraph. There's no meaning at all. We'll go back. So let us see how it works. I just take, just for your reference, I'm taking this print, and just it's coming to you, and it has come to you, and I think it's okay. Let us read this. What it says only, I think, a small page, and let's see how this works. Sometimes everything's not clear. Let's say here, concrete quality. Monitoring of concrete quality through resistivity result is much easier due to non-destructive character of measurement related terms. Okay, accessing a concrete resistance to chloride ion ingress using formation factor. Says introduction here is accessing concrete quality specifically to determine its resistance to ion ingress. Accessing concrete quality specifically to determine its resistance to ion ingress has gained increasing interest in recent decades. One particular method that has been receiving increased interest is use of electrical resistivity or conductivity to assess the transport properties of concrete. Numerous studies have correlated resistivity to diffusion coefficient and other transport coefficients. And it says, I'm not going to read these names. While these correlations have shown reasonable agreement, this page shall highlight why, when assessing concrete quality, formation factors may be preferred to resistivity alone. This chapter begins by describing background of electrical property measurement, that is resistivity and conductivity. In cementitious materials shall define formation factor. Formation factor, a microstructural material property. A microstructural material property that describes formation factor, a microstructural material property that describes pore network, can then be related to diffusion coefficients of different ionic species. Review of experimental technique needed to determine formation factors, specifically connectivity, pore volume and pore solution resistivity and discusses role of degree of saturation. Procedure used recently to determine formation factors at different degrees of saturation. An illustration of formation factor measured on Portland cement concretes saturated with different concentrations of pore solution presented, along with formation factors measured for variations in Portland cement concretes with moderate water to cementitious material ratio. Lastly, process of developing performance ranges discussed. An approximation utilizes surface concentration, reinforcement, cover depth, and formation factor to approximate a time to corrosion initiation. Remainder of chapter discuss future research need in advancing use of formation factor in specifying durable concrete materials. There's you can say, read full chapter here in science.com, etc. You can see here is self-compacting concrete. So it's a development in formulation and reinforcement concrete, 2008. Resistance to segregation says segregation significantly reduces, you can say, segregation significantly reduces concrete quality. Segregation, when the coarse aggregates and other aggregates, fine aggregates segregation significantly reduces concrete quality, which subsequently leads to problems during service life of structure. Segregation is caused by differences in gravity of constituent materials. Segregation is caused by differences in gravity of constituent materials. Differences in gravity of constituent materials. Sedimentation may affect either during flow due to stress gradients, dynamic segregation, or a settlement due to gravity, static segregation. It's defined like that. It says sedimentation may take place either during flow due to stress gradient, dynamic segregation, or as settlement due to gravity static segregation. So one is due to flow of concrete and other one is due to gravity. Sedimentation rate of a single particle. Sedimentation rate of a single particle, that is worst case, can be calculated from Stokes' law. Hydraulic in Stokes, I can say, larger density differences between particle and matrix. Larger density differences between particle and matrix. Larger particle and lower viscosity. Higher sedimentation rate. Larger particle, lower viscosity, higher sedimentation rate. Of course, when particle is large or dense, only limited fundamental research on segregation in SSC has been carried out. Okay. Now, here is piece. Here is this. We can say, all right, wait a minute, please. We can say, yeah, now to achieve cohesion and segregation resistance, to achieve cohesion and segregation resistance, viscosity modifying admixtures are sometimes added. Means we have to modify viscosity, means better, how to improve it, how to make it more viscous. Viscosity modifying. Viscosity, it's a term in hydro science, fluid mechanics. If a material is stiff, viscosity is high. If it's less stiff, viscosity is low. Viscosity modifying admixture are sometimes added to fresh concrete. Also, addition of fine particles has been proposed to facilitate robustness with regard to sedimentation. And therefore, palygorskite with aspect ratio length diameter of more than 35 is claimed to produce highly stable SCC at addition rate of 2 to 10% in combination with superplasticizer. So it is given palygorskite with an aspect ratio length diameter, that is more than 35, okay, is claimed to produce highly stable SCC, self-compacting concrete, at addition rate 2 to 10% in combination with superplasticizer. Alright, that's full chapter is referred to, that's different one. Now we have to damage analysis and cracking model of reinforced concrete structures with rebar corrosion. Damage analysis and cracking model of reinforced concrete structures with rebar corrosion. Effect of concrete quality. To examine effect of concrete quality on expansive pressure, same reinforced concrete example is used. Normally, tensile strength is considered to be a key factor in corrosion-induced cracking of concrete. Tensile strength is considered to be a key factor in corrosion-induced cracking of concrete. Concrete with a larger tensile strength always has a larger compressive strength. That's natural. Concrete with larger tensile strength always has a larger compressive strength. We chose 4 compressive strengths rather than tensile strengths to illustrate the effect of concrete quality on expensive pressures, that is 25 MPa, 35 MPa, 45 MPa, 55 MPa. All other parameters are same as those mentioned. According to Chinese code, elastic modulus EC, deformation modulus at maximum tensile stress, and tensile strength, cohesive strength, here maximum tensile stress, that is modulus, is indicated by E-C, tensile strength is Ft, cohesive strength is C, and internal friction angle phi of concrete could be calculated as shown in table, and here is calculated mechanical parameters of 4 types of concrete. One is, in terms of MP1 column, first column is FC 25, 35, 45, 55. Other column is EC, that is Young modulus, both GPa, and then FC and SC as we said in the psi. So GPa, that is EC, has E-C, and these values are given in this table. All values at 25 MPa, 35 MPa, 45 MPa, 55 MPa. It says this shows effect of concrete quality on expensive pressure. That is given here, and it can be seen from figure that peak value of expensive pressure, it can be seen from this, increases with strength of concrete. That is because better quality of concrete, illustrated by higher tensile strength shall heighten bearing capacity of concrete cover. So heighten bearing capacity of concrete cover, that is an important point. Effect of tensile strength of expensive cover, that is expensive pressure. Evaluation of concrete quality, lateral pressure test. Evaluation in situ of concrete quality, uniformity, you can say uniformity, grade of deterioration, strength, etc. becomes important when reinforced concrete structures present visible defects as fissures, lack of mortar, damage produced by fire. Evaluation of concrete of existing structures is generally made determining compressive strength, as it reflects in direct or indirect way most of other concrete properties. So it says that let me put up some page here. No, I can't put up this. Okay. Right. Well, so why I'm moving is here. It says evaluation of concrete of existing structures is generally made determining compressive strength as it reflects in direct or indirect way most other concrete properties. Determination of in situ concrete strength is made in most cases by means of tests performed on samples extracted from structure. Sometimes this procedure presents some technical problems as it's necessary to extract many cores to assure a reliable strength level. In some cases, due to characteristics of structures, cores cannot be drilled. Damage produced to structural element, high density of reinforcement, thin elements, etc. Non-destructive tests and DT are used to evaluate concrete strength in situ due to problems mentioned before. Use of NDT makes possible to determine different characteristics of concrete without producing damage or destruction of element under study, presenting other advantages as that they are quick, easy to use and economical. During last years, many studies have been made on application of different NDT, and also new testing methods have been developed. In Argentina, several NDT based on different theories of fracture were developed. Methods of localized pressure, torsion, and lateral pressures can be mentioned. It must be mentioned that using NDT available at present, absolute values of strength cannot be obtained. Nevertheless, some NDT quantify some properties of concrete directly or indirectly related to mechanical strength. Strength can be estimated with errors that are acceptable. In this paper, results of some studies performed with method of lateral pressure are informed. Relationships between compressive strength and rupture loads quantified with NDT are established on concrete of different characteristics. Variables as strength level, age, type of coarse aggregate, and curing of concrete are also analyzed. Assessment of structures in industrial plants. Important point, we call them facilities. Concrete cover measurements. Thickness of concrete cover measures is usually part of concrete quality control in modern construction so as to ensure the thickness of concrete cover is in conformity with specifications. Process of measuring thickness of concrete cover in structures was noted by beginning of corrosion, as lack of concrete cover thickness increased corrosion rate for corrosion as a result of chlorides or carbonation, where it expedited propagation inside concrete, causing speed of steel corrosion, as well as lack of cover helps propagation of moisture and oxygen, which are formed main basis for corrosion process. Measurement of concrete cover thickness explains causes of corrosion and identifies areas that have capability to corrode faster. Measurement of thickness of concrete covers needs be defined x and y axis in order to determine thickness of concrete cover at every point of structure. Equipment which measures thickness of concrete cover is simple and high technology, as you can obtain measurements as numbers. Electromagnetic cover meter shape and method of testing. This is not available in this, no problem. Now radiographs can be used on bridges but are quite expensive. Magnetic cover method is simple method, but accuracy is affected by distance between steel bars, and when thickness of concrete cover is large, influence in readings significantly. Since this method depends on supply of electricity through 9-volt battery, second side of measurement for potential voltage envelopes envelope when completed by steel bars is buried as shown. Figure is not seen in this, no problem. Device location on concrete surface. Well, shall increase accuracy of reading. Small head has an impact on accuracy of equipment. Problem of this method is case of dense steel reinforcement in concrete section that give non-accurate data. In this case, equipment shall be calibrated based on existing steel bars as reading be affected by type of steel. Person who works on equipment must be competent and aware of whatever that can affect reading, such as bolts, steel wires. Sustainability of concrete. Other parts, let's say, approaches for improving sustainability described above are all perfectly feasible with our current understanding and technology at modest cost. However, there are a number of other strategies that might also be followed. These are not necessarily fully developed as yet, and may not be economically viable at this stage, but form at least a part of roadmap for future. Some of these: use of alternate clinkers. We know that we need have certain proportions of CaO, SiO2, Al2O3 and Fe2O3 in raw kiln feed in order to produce Portland cement clinker. Historically and to present day, principal source of CaO has been limestone, CaCO3. So calcium oxide that comes from CaCO3, and it is carbon dioxide created from breakdown of limestone. When it is heated, that accounts for about 60% of carbon dioxide emissions from manufacture of cement. 60% carbon dioxide emissions from manufacture of cement. However, from ternary phase diagram CaO to SiO2O, Al2O3, it may be seen that there are other combinations of materials that could be used to make cement. They are simply not economical viable. This figure is not seen, but it says shaded area presents composition. Well, okay. Now, same type of ternary phase diagram shows more simply approximate composition of slags, fly ash and anodized Cal2, Si2, Portland cement clinker could be blended with an appropriate combination of one or more of these cementitious materials, again with a considerable reduction of carbon dioxide emissions. This is only done in large scale in places such as Belgium and Netherlands, and there is no reason why this practice should not become much more widespread elsewhere. I think this paper has ended. Now it's about schematic representation of composition of slag, class F and class C fly ash, anorite and natural clays. For example, Portland cement clinker based largely on belite C2S can be made using essentially same equipment and technology as are used to make Portland cement. The main drawback is that they gain strength very slowly compared to ordinary cement. This, however, an advantage if they are used in mass concrete, massive concrete, where a low rate of heat evolution during hydration is desirable. Another possible alternative is to add yeelimite Ca4 Al2SO8, also known as calcium sulfoaluminate. Calcium sulfoaluminate, that is formalized as Ca4Al2Si2O8 calcium sulfoaluminate to basaltic clinkers. Calcium sulfoaluminate cements have been developed mostly in China but are still too expensive except for certain niche markets. Performance versus prescription. Performance versus prescription specifications. In our approach to mixed design, we still rely mostly on prescriptive specifications. That is, specifications most often include requirements such as minimum binder content, maximum water binder ratio, type of cement, types and or amounts of admixtures and filler materials, and so on. Unfortunately, while such specifications served us well in past, particularly when cement and concrete industries were less sophisticated, they inhibit most efficient use of many materials available to make up concrete mixtures. Such specifications also tend to be very conservative and are not only receptive to new materials or processes. It would be much more efficient in terms of both sustainability and concrete quality in general to move more aggressively to performance-based specifications. There are a number of different definitions of performance-based specifications, but their essence is contained in with Canadian Standard CSA 823, which reads as part. Okay. A performance concrete specification is a method of specifying a construction product in which a final outcome is given in mandatory language in a manner that performance requirements can be measured by accepted industry standards and methods. Processes, materials, or activities used by contractors, subcontractors, manufacturers, and materials suppliers are then left to their discretion. Intent is clear. Prescribe required properties of both fresh and hardened concrete, but without saying how they are to be achieved. Properly written performance-based specifications would permit concrete producers to be more imaginative, competitive and innovative in their use of materials. such as SCMs, admixtures, blended cements, mineral fillers, locally available materials, and so on. They would also provide a way of introducing durability concerns more explicitly into design of concrete mixtures, as well as implicit in move to performance-based specifications is necessity for owner, contractor, and material supplier to work together. Owner specifies required properties which could even include a carbon footprint. Supplier assumes responsibility for delivering appropriate concrete to site, and contractor assumes responsibility for placing and curing concrete property. Environmental degradation of reinforced concrete. See, I'm just referring to these notes only because these are not full chapters. We have to read chapters you want to read. It's not a perk issue. Low permeability concrete. A good one if it's low permeability means that's what's desired. Low permeability concrete. Traditionally, first step in improving durability of reinforced steel involved improving concrete quality. For example, ACI 318 and ACI 357 recommend water to cement ratio of 0.4 or under, and minimum cover 50 mm for non-marine and 68 mm in marine exposures. ACI 318 2003, ACI 357 2003, other codes such as Euro Code 2 and Norwegian Code and 53474 are less stringent than 02 1992 Norwegian Code. Additional means of reducing ingress of chloride. Additional means of reducing ingress of chloride into concrete involves addition of pozzolans or ground blast furnace slag. These materials are often added as cement substitutes. These react with calcium hydroxide to reduce coarse porosity. These react with calcium hydroxide to reduce coarse porosity of concrete and to decrease porosity at paste aggregate. Interfaces. Several conferences proceedings documents positive benefits of these materials are given. Numerous references show that even if concrete is produced to most stringent of codes, chloride shall ingress into concrete and corrosion of steel reinforcement shall initiate. So, there's a limitation on this. Says numerous references show that even if concrete is produced to most stringent of codes, chloride shall ingress into concrete and corrosion of steel reinforcement initiate. Even for very low permeability concretes, chloride shall eventually ingress into concrete and initiate corrosion. When chloride ingress is modeled as a function of water, cement, paste, and pozzolana contents for various geometries and environmental exposures, time to corrosion in excess of 25 years are difficult to achieve. For low permeability, concrete. Thus, additional protection systems are necessary to meet extended design lives that are becoming increasingly specified. Design and engineering of biogas plants. Reactor material and protection. Digestion tanks of RCC and steel are most widely used. Reinforced concrete tanks benefit from high tensile strength of steel and high compressive strength of concrete. Appropriate concrete quality, blast furnaces, cement and low lime content, and professional construction are important to prevent corrosion and leaks in tank walls. Concrete digesters can be built partially or completely in ground. Steel digesters are built on concrete foundations above ground. Steel plates are welded or bolted together and seams are tightened. For parts in contact with corrosive fluids, higher quality stainless steel is recommended. Glass coated or glass steel is used when there is no risk of corrosion. Vulnerable parts of reactor should be protected by coatings or liners in order to avoid corrosion. Substrates, biogas and condensate can contain aggressive substances, namely hydrogen sulfide, ammonia, organic acids, and even microbes that disintegrate. Consider concrete and plastic that disintegrate concrete and plastic. In steel and concrete reactors, built from high quality materials, zone in contact with substrate does not normally need protection, but zone in contact with gas should be protected by a plastic layer in order to resist small deformation or hairline cracks in materials. It must also be resistant to temperature variations, humidity, and to aggressive substances that may be resident within reactors. Bitumen emulsion paints for underwater use, polyurethane, polystyrene, or epoxy are used for coatings. These are applied by painting, spraying, or by spatula and must form a tight and completely covering layer. Application of a primer can be helpful, especially in case of rough surfaces. Lining sheets are another protection option. Polyethylene tiles or films can be set up in cast form and sealed. Understanding dynamic response of concrete to loading, practical examples. Project examples: improving blast resistance. Research and development in engineering is directed towards practical application. Usually, actual projects are much more complicated than textbook examples. In following, we provide executed projects. Our reader can understand that projects chosen cannot be described in such a way that they are identifiable. Also, giving physical data, geometrical sizes, charge, weights or concrete quality is avoided. Examples show practical importance of concrete material for protective structures. Mitigation of explosive effects using sandwich walls. Mitigation of explosive effects using sandwich walls. Following project had two objectives. Firstly, to assist an existing building, and secondly, if necessary, design it to be blast resistant. It's the important one. Mitigation of explosive effects using sandwich walls. Project had two objectives. Firstly, to assess an existing building, and secondly, if necessary, design it to be blast resistant. For an existing building, threat level or head horizon, and this had led to assessment that the structure was not strong enough. Therefore, a new design had to be developed without changing original architectural layout. Sandwich walls can be very efficient in mitigating explosion effect. In present situation, a close in explosion and resulting blast had to be considered. Now there is a plate that shows basic load transfer concept. It shows a 3-layer wall comprising a first concrete layer, an interlayer, and a second concrete wall, comprising a first concrete layer, that is comprising a first concrete layer, an interlayer, and a second concrete layer wall. Concrete is typical ordinary concrete and type according to Euro Code 2. Interlayer can be of air form dry sand, or whatever that results in high impedance, as can be seen in blast wave hits first the concrete wall. Coming from left, this results in a compressive shock wave traveling through material. At interface between first concrete wall and interlayer, a part of shock wave is transmitted into interlayer depending on impedance, and the part is reflected as tensile wave. Ratio of transmitted and reflected shock waves depends on impedance ratio, which is impedance ratio is defined as product of density and wave velocity. density and wave velocity. Concrete has a, say, impedance is defined as product of density and wave velocity. Concrete has a density of roughly 2500 kg per meter cube and the longitudinal wave velocity of approximately 3700 miles. Yes. Now impedance is defined as product of density and wave velocity. Concrete has a density of around 2500 kg per meter cube. Now we go further on this. We say, let's see here, ratio of transmitted and reflected shock wave depends on impedance ratio, and we have already defined impedance ratio as product of density and wave velocity. Impedance is that, impedance is product of density and wave velocity. Concrete has a density of roughly 2500 kg per meter cube and a longitudinal wave velocity of approximately 3700 meters square per gram. So we can say, and a longitudinal wave velocity of approximately 3700 meters per second. Density is 2500 kg per meter cube and longitudinal wave velocity of approximately 3700 meters per second. That is, which yields in impedance of 9.25 MPa. Velocity of approximately 3700 meters per second, which yields an impedance of 9.25 MPa. This is much larger than impedance of air, density 1.225 kg per meter cube. Wave velocity 340 meters per second. Air ocean. Then we can say this is much larger than impedance of air, that's 1.225 kg per meter cube. Wave velocity 340 meters per second, impedance 416 MPa. And impedance ratio is approximately 22 to 9. Alright. From, you may say, when I say impedance is for 16 and impedance ratio is approximately 1:22. Well, air concrete, that is, air is alright then. From this it is seen that air is an ideal interlayer theoretically. However, due to practical reasons on construction site, construction technique and process, low density foams or other materials with small impedance were used instead of air interlayer. Furthermore, a foam interlayer also serves as an impact cover for second concrete wall if first one is damaged. A damaged cloth for a protective sandwich wall. Effect of impedance at interface between first concrete wall and foam in interlayer can be identified. A small part of blast energy is transmitted through foam interlayer into second concrete wall. However, strain state in second concrete wall is much smaller than first wall. We observe significant damage indicated by certain red line. Energy dissipation in first concrete wall. Reflected tensile wave at rear face of first concrete wall. Effective tensile wave at rear face of first concrete wall results in tensile stresses in concrete material which can be much larger than dynamic ultimate tensile strength of concrete. This leads to scabbing failure on rear face of first concrete wall. But foam interlayer was chosen. Such that it prevents concrete fragments from impacting second concrete wall. Consequently, requirement that rear wall should stay intact could be fulfilled. In next example, task was to harden an existing building. Existing concrete walls had to be protected against a contact detonation. Fire control authorities had formulated very strict requirements due to available space for hardening measures. In addition, protection requirement for existing wall was acceptance of certain damage. Therefore, a high strength, high ductility concrete was developed and analyzed. Again, say slayered sandwich wall subject to contact detonation. The left design high strength, high ductility protection, wall right immersion. High strength, high ductility concrete wall concrete will be described in following section. Result is shown on right. Okay, leave it. Protective cover wall serves as victim wall. Protective cover wall serves as victim wall. Interlayer mainly provides distance and existing wall is damaged acceptably. Blast walls. We are often asked to design blast walls. They give subjective feeling of being better protected. In fact, in fact, give protection from contact detonation, flying fragments, flat trajectory fire, blast in a close range behind wall, and they act as blinds if they have to be designed in an urban environmental situation where, in addition, the requirements from monument conservation authorities exist. It becomes a real challenge. Even design of concrete foundation can become a complicated task if trees have to be preserved or if supply and waste lines cross foundation. Solution was chosen after several options were studied. Foundations are made of ordinary reinforced concrete carrying clamped steel posts. High strength and high ductility concrete points panels protect from blast. High strength, high ductility concrete panels protect from blast, contact detonation, and impact. Because of their ductility, they can develop a good flexural behavior and consequently achieve membrane actions. I think it's gone. No, it's not gone. Still there. High strength, high ductility concrete is a product of Decon. Okay, German company, leave it. I'm not commercially interested in this. This is Decon. Okay. It says Decon self-compacting concrete micro mat. Compression strength goes up to 200 MPa and tensile strength reaches 75 MPa. Compressive strength goes up to 200 MPa. And tensile strength reaches 75 MPa, which is roughly 40% of compressive strength. Therefore, such materials can be favorably used where high tensile resistance is required. Now, combined effect is a figure here which gives an overview of huge historic building, which is in fact a multi-purpose building for governmental and private use. Security authorities had defined threats. It was the task of authors to provide advice based on numerical studies. Initial general studies provided overall blast situation, including exterior and or interior explosions. Based on these studies, doors, windows, openings, and facades were investigated individually. In addition, numerous detonations on load-bearing structures were investigated numerically for the same. Relevant portions were cut out of structural in order to model representative substructures and underground car parks subject to a car bomb. Upper concrete plates and concrete walls are not shown. In further steps, each significantly affected structural element was analyzed. In every single project, it needs to be discussed whether ordinary concrete should be used or specially designed concrete. From author's experience, it can be said that in using high strength, high ductility concrete, structure can save roughly half of geometric size of ordinary concrete. So this was, I think this is ended. Concrete quality and overview, so this is gone. State building multiple purpose. We will now, I close this paper. Caution. At the end of study, results were discussed with the structural engineer, who is normally different from safety engineer. Consequences for load-bearing structure were assessed in order to avoid partial or entire collapse. These results were communicated to architect. All right, now I'll just save this page for reference in future if required. It's better to keep record of such thing. Okay, now what to do? Just a minute, please. Let me just hold it. Just a minute, let me save it and close it, then no problem. I close it twice, So degradation consideration we're talking, and let me see if we can get more information from this page. That is concrete quality, and I go to, this is corrosion of steel and concrete structures. Let us see. Let's go to now quality issue. There's something else, and that is quality and durability of concrete, NBMW. Let us see. I think it's also in many pages. This says NBM and CW Infra Construction Equipment Magazine. This paper discusses quality of concrete. This is the lifespan of present day concrete structures in India. Paper main focus is on durability of concrete. How to see? Let us see what it says. Let us take print off of this and see how it works. Maybe 4 or 5 pages. And how much we are talking, let us see. This also very important, where we do stand. Let me take print of this and show to you what it says, because various sources are required, various information is required. Let me put on my battery also, because I am using internet fast. So let us see how it works. Just a minute, please. I'm showing you this. I'm showing you this. This is a page coming up, and this Indian page. Let us see what it says. I have to scrutinize all this. Scrutiny is very important. Sometimes references are good. We can get something to know what's happening. And here is, we can say, it is now, here is now it says this paper discusses quality of concrete vis-a-vis lifespan of present day concrete structures in India. Paper's main focus is on durability of concrete, how to produce good quality durable concrete structures with available concrete making materials. Focus is on materials like aggregates, mineral admixtures like fly ash, GGBS, silica fume, and on mixing, placing, compaction and curing of concrete. Use of blended cements to produce durable concrete structures, and details on concrete mixes using used for M70 and M80 grades of concrete using such cements in developed countries have also been highlighted. Concrete is a mixture of cement, water, aggregate and admixtures. Chemical admixtures change initial characteristics of concrete, namely setting time, workability, cohesiveness, fluidity. Mineral admixtures, namely fly ash and ground granulated blast furnace slag, modifies resisting capacity of concrete in aggressive environments. And bleeding concrete, and they being fine materials, help in producing a cohesive non-bleeding concrete mix. Thus, concrete is a versatile construction material. Its characteristics can be made as desired. Using suitable concrete making materials and their right proportions, basic characteristics of concrete and workability this page. Thus, a concrete is a versatile construction material. Its characteristics can be made as desired. Using suitable concrete making materials and their right proportions, basic characteristics of concrete, that is workability, there is fluidity and cohesiveness, and 28 days compressive strength, can be obtained as desired using suitable proportions of constituent materials. Cement is binding material in concrete. 28-day compressive of flexural strength of concrete mostly depends on water cement ratio or water binder ratio, and 28 days compressive strength of cement. Water reducing admixtures reduce water content of concrete, and thereby compressive strength of concrete can be increased by reducing water binder ratio. Thus, different grades of concrete, M20, 30, 70, etc. can be produced without altering water content or water binder ratio for a particular grade of concrete. Workability of concrete can be increased with use of superplasticizers, thus in heavily reinforced concrete sections. High workability concrete can be placed without much compacting efforts. In mass concrete structures, bigger size of coarse aggregate are used. Air and training admixtures are used to produce cohesive concrete mix in such cases. Mineral admixtures like fly ash or GGBS reduce heat inside concrete. Thus, PPC containing fly ash or PSC containing GGBS can be used as low heat cement for producing very high strength concrete, say M80. Efficient superplasticizers reducing 30 to 35% of mixing water be required. Along with high strength OPC, mineral admixture silica fumes, 8 to 10% by weight of cement shall also be required to produce such high strength concrete. Silica fume concrete is also abrasion resistant and therefore is being used in construction of spillways of concrete dams. Long-term strength and durability of concrete are important characteristics of concrete. Concrete structures must provide designed service life. Timely maintenance of structure is essential to obtain desired service life. In spite of good quality cement being manufactured these days, service life of concrete structures is not increasing. Indian construction industry should rise above certain level and produce concrete structures which have long service life. Use of mineral admixtures in concrete, fly ash, ground granulated, blast furnace slag, and silica fume have been recommended to be used in concrete as mineral admixtures. Fly ash and silica fume are good pozzolanas, whereas GGBS is a latent hydraulic material. Fly ash and silica fumes are good pozzolanas, whereas GGBS is a latent hydraulic material which also reacts with lime liberated due to hydration of OPC in concrete. Silica fume is very fine, non-crystalline silicon dioxide. Silica fume is very fine, non-crystalline silicon dioxide, a byproduct of ferrosilicon industries. It is presently being imported in India from Australia, Norway and China. Generally 5 to 10% silica fume by weight of cement is sufficient to produce high strength concrete, M60 grade and above. Being a highly reactive pozzolana, it develops also early strength of concrete. Silica fume, about 8% by weight of cement, has been used in spillway of Tehri Dam for abrasion resistance. In spillway of Kaul Dam, Himachal Pradesh, it is proposed to use about 10% silica fume for M80 grade concrete. Good quality fly ash is available from electrostatic precipitators of our super thermal power stations, but quantity of grade 1 fly ash is not sufficient to be used to produce Portland pozzolana cement, PPC, bought by cement manufacturers. Requirement of such fly ash by our ready mix concrete plant is also very high. It's observed that because of insufficient quantity of good quality fly ash, cement manufacturers are grinding coarse fly ash to required fineness to produce PPC of pozzolana Portland cement of minimum fineness of 300 meters square per kilogram. This is pozzolana cement, that is PPC, as I said, it's gone. Portland pozzolana cement, yeah. It's observed that because of insufficient quantity of good quality fly ash, cement manufacturers are grinding coarse fly ash to required fineness to produce PPC of minimum fineness 300 kilogram, 300 meters square per kilogram. By this process, ball bearing effect of spherical shapes of fly ash particles is lost. Ball bearing effect of spherical shape of fly ash particles is lost, and consequently beneficial properties of fly ash, namely lower water demand and increased workability of concrete, are lost. We use fly ash in concrete because as a pozzolana it has good effect in concrete and you get a cohesive concrete mix. In mass concrete, heat development inside concrete is less. Heat development inside concrete is less. Sometimes it substitutes part of cement and sometimes part of fine aggregate also. When quality of fly ash is not good, it still has beneficial effect. Reactive silica of such fly ash may be in less quantity, but in long run, part of such fly ash goes to provide a denser microstructure. Reactive silica of such fly ash may be less in quantity, but in long run, part of such fly ash works to provide a denser microstructure. In such case, use of chemical admixture, that is superplasticizer, has a major role to play. It should reduce water binder ratio as low as practicable. With reduced water binder ratio, permeability of concrete gets reduced and result in increased compressive strength in long run. Therefore, it is expected that low quality fly ash in conjunction with use of compatible and efficient superplasticizer shall provide long service life for concrete structures. What is expected is low quality fly ash in conjunction with use of compatible and efficient superplasticizer provide long service life for concrete structures. Proper mixing of concrete, adequate compaction, and longer curing period definitely provide durable concrete structures in such cases also. Mineral admixtures, that is fly ash, GGBS, and silica fume, being very fine particles, that is mineral admixtures, fly ash, GGBS, and silica fumes, being very fine particles, their uniform blending with cement and aggregate. Uniform blending with cement and aggregates in ordinary drum mixers can not be ensured. In most our construction sites, batching and mixing plants are not available. Therefore, it is suggested that slurry can be made with mineral admixture and part of mixing water in drum mixer before placing cement and aggregate. IS 456 stipulates that mixing of concrete in concrete mixer shall be continued until there exists an achieved uniform distribution of materials and mass is uniform in color and consistency. If there is segregation after unloading from mixer, concrete should be remixed. Mixing time shall be at least 2 minutes for drum mixers. For efficient concrete mixers, as in RMC plants, manufacturers' recommendations shall be followed and trials may be carried out to produce cohesive concrete mix using proper combined grading of coarse aggregate fractions. In our construction sites, generally drum mixers are used. Although minimum mixing time for concrete has been fixed 2 minutes, in many cases it has been observed that concrete mix is not a cohesive one and is not uniform in color and consistency. Cohesive, that's not segregative, concrete mix can only be placed properly in formwork and compacted well. This process of placing a cohesive mix around reinforcement and fully compacted and finished well has got considerable influence on durability of concrete. Adequate cover to reinforcements, dense concrete cover, and well compacted concrete cover shall not get carbonated during its service life. To get maximum benefit out of mixing of concrete, it is suggested a two-stage mixing. Firstly, Dry mixing of materials with covered mixer drums and then wet mixing process. Japanese researchers used nailing of concrete mass, a small quantity of water, and then wet mixing process. Laboratory data of such two-stage mixing indicate higher compressive strength and lower permeability of concrete. In mixing process, part of mixing water should be placed in concrete mixer in beginning and chemical admixture along with rest of mixing water should be placed towards end of mixing. This procedure provides a concrete of uniform color and consistency and a cohesive concrete mix. Housing are suffering a great setback because of improper mixing and compaction of concrete. How can we expect durable concrete structures when quality of concrete placed is not good? Normal drum mixers are not available in rural India. Concrete vibrators are not used because of non-availability of electricity. In such situation, although rural concrete roads are supposed to be of M30 grade and RC slabs, in houses are supposed to be of M20 grade. Real scenario is terrible with hand mixing of concrete and with rodding of concrete in formwork. No durable concrete can be produced. Result is shorter life and shorter lifespan of concrete structures. In rural India, diesel-operated concrete mixers and vibrators can be used to produce cohesive concrete mix and placed compacted efficiently. However, if hand mixing is only alternative, 10% extra cement to be added to concrete mix and mixing time to be increased in order to obtain a cohesive concrete mix. Lifespan of concrete structures. In India, we design buildings for a lifespan of about 50 to 60 years. Bridges are designed for about 100 years, while concrete dams are designed for about 150 years. Delhi metro structures have been designed for 120 years. Eurotunnel connecting England and France undersea has been designed for 120 years. Although buildings are designed for 50 to 60 years, it has been observed that buildings have longer lifespans. Our buildings in Mumbai and Kolkata develop distress at about 100 years age. With availability of good construction materials in present day, our structure should provide longer service life, provided we build them with adequate care. Using proper method of mixing, placing, compaction and curing of concrete. In addition to mineral admixtures like fly ash, GGBS and silica fume, chemical admixtures, namely superplasticizers, provide required workability and compressive strength of concrete. But because both cement and chemical admixtures are chemicals, their compatibility must be ensured before use. Fortunately, a large number of chemical admixtures companies are operating in our country, especially in cities, and materials like plasticizers, superplasticizers, normal and retarding type, accelerating and retarding admixtures are available in good quality and quantity. Only their proper doses and compatibility with different types of cement, if ensured, provide cohesive, workable concrete mix, which can be placed comfortably in formwork and compacted well. Thus, production of good quality concrete Their proper placing, compaction and curing shall ensure longer lifespan of structures. In normal mild exposure condition, structures shall have required service life, but in aggressive environmental conditions, these require special care and protection. For example, in marine environment or in heavy rainfall areas or where aggressive chemical environment exists, concrete structure should be built with required materials and protected well. In sea environment, chloride and sulfate reduce service life. Sulfate attack concrete and chloride corrode reinforcement. Sulfate attacks concrete and chloride corrode reinforcements. In such situations, caudal provisions must be followed. With use of superplasticizers, water cement ratio can be reduced as low as possible, maybe in range of 0.35 to 0.4, so that permeability of concrete gets reduced. Portland slag cement with more than 50% slag content is suitable. Portland slag cement with more than 50% slag content suitable in case both sulfate and chlorides are encountered in environment. For severe conditions such as thin sections under hydrostatic pressure on one side only and sections partly immersed, consideration should be given to use a water cement ratio or water binder ratio. In case of use of mineral admixtures, as low as possible. IS 456 states that Portland slag cement conforming to IS 455, slag content more than 50% exhibits better sulfate resisting properties. For thin structures, life can be increased by providing extra cover to steel reinforcement by chamfering corners or by using circular cross sections. By chamfering corners or by using circular cross sections or by using surface coatings which prevent or reduce ingress of water, carbon dioxide or aggressive chemicals. For high sulfate concentration that is more than 2% in soil or more than 5% in groundwater, IS 456 stipulates use of protective coatings on well-made or well with lower water ratio, osmotic ratio, and with proper cement concrete surfaces. Coatings can be based on asphalt, chlorinated rubber, epoxy, or polyurethane materials. So coatings can be based on asphalt, chlorinated rubber, epoxy, or polyurethane materials. In severe exposure conditions, that is in marine environment, in many places, fusion bonded epoxy coatings have been used in steel reinforcement. TMT bars and metallurgically changed corrosion resistant steel bars are definitely going to increase service life of concrete structures near sea. Polymer based coating to steel reinforcement have been found useful. Concrete aggregates. Use of good quality aggregates definitely increase service life of concrete structures. In many places in India, good quality riverbed sand is not available. Sometimes only very fine sand is available. Sand and coarse aggregate must be strong and good. In order to produce durable concrete structures, well-graded aggregates provide a dense concrete mix. Crushed rock coarse aggregate from strong rocks like basalt, quartzite, granite, etc. are angular, and they provide good bond in concrete and develop strong concrete. Flaky and elongated coarse aggregates should be avoided if possible. Crushing, impact and abrasion values of coarse aggregates shall not exceed limits specified in IS 383. Fine aggregates should generally be of grading zone 2. Fine aggregate should generally be of grading zone 2 or grading zone 3. For very high strength concrete, coarse graded, fine graded, zone 1 is suitable. Sometimes riverbed sand is not available, so we use crushed stone fine aggregate. They can also produce good quality dense concrete, provided their grading is satisfactory. Deleterious materials like clay, lump, coal, lignite, shale and soft fragments should be avoided. Use of good quality well-graded coarse and fine aggregate definitely increase service life of concrete structure. Use of blended cement. Our cement manufacturers produce more blended cements. Portland pozzolana cement is about 50% of total cement production. PPC is with about 20% fly ash. Portland slag cement is a good quality cement and with slag content of about 40 to 50%. But this cement is limited, about 15% of cement production. This has become a special cement because of its availability near steel plants. Slag, blast furnace slag, is a consistent material and therefore is of low variability. Use of PSC has become important because this cement is in concrete can resist very aggressive environment and hence increases lifespan of concrete structures. It has been prescribed to be used in sea environments and also in concrete dams. PSC in concrete can resist alkali-silica reaction in concrete. In aggressive environments, namely in concrete piles, in sea environment, in Gujarat, PSC with 70% slag has been used in produce high workability M40 grade concrete. The pull concrete mix proportions used are as follows. GGBS 70%, 329 kg, sand 41%, 720 kg, coarse aggregate 20 mm, MSC 1044 kg, retarding superplasticizer 0.8%, OPC by weight of OPC and GGBS. In mass concrete, both PPC and PSC are advantageous. When I say mass concrete, this is massive block, please just keep it in mind. You should just copy paste, but I don't know how to say. Mass means massive. Mass concrete, both PPC and PSC are advantageous because of low heat of hydration and also because alkali is not fully effective. Typically, about 1/6 of alkali of fly ash is potentially reactive and about 50% of alkali of GGBS is effective. For underground structural elements of cut and cover tunnels and station boxes, 30% fly ash has been used for M35 grade of concrete in Delhi Metro Project 5. Delhi Metro structures have been designed for 120 years. Water cement fly ash ratio has 0.04, 0.4, and slump of concrete was 120 mm. In Salus mono tower cable stayed bridge in Norway, PSC was used. Bridge superstructure. Main span is 163 meter. Following mixed proportions were used for 70 grade of concrete. PSC 450 kg, silica fumes 35 kg. So less than 10%, you can say PSC is 450 kg, silica fumes 35 kg. This is about, I think, 8%. Less than 8%. Lightweight aggregate 470 kg, and water 195 kg. So it's about 450, 35, 45. So about that. At Kuala Lumpur city center, there are 450 meter high twin water towers. At Kuala Lumpur city center, there are 450 meter high twin towers made of RCC core and columns and composite steel concrete deck floors. Fly ash was used in concrete. For a grade of MAT, concrete admixture was used to produce 200 mm slump of concrete. Elastic modulus of such concrete at 56 days was 35.5 GPa. Total alkali in concrete was less than 3 kg per meter cube of concrete. This satisfies BRA recommendations 6 for resisting alkali silica reactions in concrete. Construction of Eurotunnel under sea 50 to 50 meter below sea level is designed for 120 years. Each tube is composed of rings made of 5 segments. There are total 226,000 segments and 500,000 meter cube of concrete used. Each tube is composed of rings made of 5 segments. There are total 226,000 segments and 500,000 meter cube of concrete is used. Length of tunnel is 51 kilometers, of which 37 kilometers under sea, 4 kilometers under land or French side, and 10 kilometers under British end. Tunnel lining concrete precast is M45 grade, and the cast in place concrete is M30 grade. For tunnel lining concrete, low C3A was not recommended. In marine environment, C3A is important to trap chloride ions entering concrete. OPC with 5 to 8% C3A was used. For cast, this is for tunnel lining. For cast in place M30 grade, durability of concrete was of more concern than its strength. 3 blended cements were used, one blend containing 51% OPC, 25% slag, and 24% fly ash. One blend of 70% PSC with 82% slag and 30% fly ash for RCC. One blend of 72% PSC and 28% fly ash was for unreinforced concrete. The conclusion is, now this writing provides definition, durability and applications of concrete of various grades and various constituents. Use of chemical and mineral admixtures along with good quality cement can produce concrete of whatever desired grade. And if properly constructed, service life of concrete structures can be enhanced. Mixing procedure and mixing time have considerable influence on quality of concrete in terms of its cohesiveness and workability. Concreting in rural India has to be given special importance as producing and placing good quality concrete have become difficult in absence of electricity and proper mixing and placing equipments. This paper further discusses use of blended cements to enhance durability of concrete structures and provides details on concrete mixes for M70 and M80 grades of concrete used in developed countries. Finally, paper provides details on selection of concrete making materials, especially on blended cements for Eurochannel. That this white cement in India. White cement in India. It is high demand for white cement in countries with hot climates as more cement is reflected from white concrete surfaces as compared to standard grey concrete as value added product. Microfibers increasing life of concrete. Jerry Martin, Director, Major Projects, Law and Concrete. This is all alternatives. Ready-mix concrete helping construction achieve standards. This is something that is reasonable there. No, I think there's nothing in this. It's all commercial. I'm not interested in that. So nothing really. Commercial is not important for us. Let us just, if I can save this, let me say for record purpose. Save as we can say for record purpose only. Concrete I can write for our reference only. Alright, I close this file as well now, and let's go back to our program as I said here. Now I'll go back to this. So it was concrete quality indicative concrete. Now concrete quality free software. No, that's not interested in. Quality assurance of concrete topic. Quality concrete and contractors and Secondra for Gurgaon. No, this is not. Concrete quality control test inside. Concrete quality ensure concrete quality. Density of hard concrete can have a significant impact on stability, durability, strength, and resistance to permeability. Density can be measured either by. So let us see if we can have something here. Let me see what it says. If it says something reasonable, we can share it. Ensuring quality. I think it's also something. Let us say for a few, so maybe 2 or 3 pages. Acorn, Industrial Service Limited. Acorn. And what it says, let's see. The print out and see if we have size for some of this. I'll take up this paper if it has some material access to continue our talk discussion. Let's see how does it work. Now this is ensure accord digital work says proven solutions to help you. I'm not interested in this advertisement. My point is here. They say that what it says listed in concrete. Okay. Carried out to meet client's requirement and ensure safety, explains Johnson Group Marketing Manager. Okay, let's see. With a wide variety of quarried materials. With a wide variety of quarried materials used as aggregates in concrete, a combination of properties can be achieved to meet requirements of this employee. Okay. With a wide variety of quality materials used as aggregates in concrete, a combination of properties can be achieved to meet requirements of a specific application. To ensure that mix meets these specifications, in addition to testing aggregate for properties including particle size, shape and texture, density and chemical resistance, it's vital that concrete incorporating aggregate is tested thoroughly and accurately. Latest generation of sample testing technologies allow concrete to be tested considerably more efficiently and reliably than has previously been possible, helping to realize sound structures, improve long-term safety and reduce cost. So it is about with wide, I repeat because this is a requirement, with a wide variety of quarried material used as it is a concrete combination of properties can be achieved to meet requirements of specific application. To ensure that mix meets these specifications, in addition to testing of aggregate for properties including particle size, shape and texture, density and chemical resistance, it's vital that incorporating aggregate is tested thoroughly and accurately. Latest generation of sample testing technologies allowing concrete to be tested considerably more efficiently and reliably than has previously been possible, helping to realize sound structures, improve long-term safety and reduce cost. Testing aggregate. Ensure concrete. Let me meanwhile close this file. I'll open it again. Alright, okay, then I'll see. Now it says before aggregate is supplied for use in concrete mix, it should be tested to determine whether it offers necessary properties. Qualities crucial for one type of application may be unsuitable for another type. So tests required vary depending on what concrete is to be used for. Specific sampling techniques and procedures are documented in various standards, including BS 812 Part 101, ASTM B75. In general, however, aim is to obtain samples that are representative of average quality and then use either riffling or quartering techniques to reduce a bulk sample to a size suitable for testing. Riffling is typically used to reduce material in a dry condition, while quartering can be used to reduce damp material down to quantity able to be subsequently dried and riffled. In this process, a sample is flattened, divided into quarters, and two opposite sections discarded. Remainder is then remixed and quartered again, and procedure repeated until a sample of required size is obtained. So let's see what's this. Specific sampling techniques and procedures are documented in various standards. In general, however, aim is to obtain samples that are representative of average quality and then use either riffling or quartering techniques to reduce a bulk sample to size suitable for testing. Refilling is defined here, typically used to reduce materials in tight condition, while quartering can be used to reduce damp material down to a quantity able to be subsequently dried and refilled. In this process, a sample is flattened, divided into quarters, and opposite sections discarded. Remainder is then mixed and quartered again, and procedure repeated until a sample of required size is obtained. It's often necessary to determine particle size, shape, and texture of aggregate. This is done primarily by observation and use of sieves and shakers. An aggregate may be rounded, water-worn, or shaped by attrition. Irregular, either naturally irregular or partly shaped. Angular, well-defined, flaky, with small thickness in relation to its other dimensions, or elongated with a length larger than its other dimensions. Likewise, a sample may be categorized as glassy, smooth, granular, rough, crystalline, or honeycombed. In addition to size, shape, and texture, density of an aggregate may also be measured. Particle density in milligram per meter cube can be determined using a number of methods which are specified in relevant testing standards depending on type and size of material to be tested. A common method of testing density is by using a buoyancy balance, which typically consists of a rigid support. A common method of testing density is by using a buoyancy balance, which typically consists of a rigid support frame incorporating a water tank mounted on a platform. Mechanical lifting device is used to raise the water tank through a frame 8 meet, allowing specimens suspended below balance to be weighed in air and water. A number of tests can be carried out on aggregate to measure how it will react in presence of organic matter and certain chemicals. Typically, chloride and sulfate content are measured using test strips. Data obtained from these tests can be used to ensure that necessary precautions are taken in mix design stage of a project. To avoid potential weakness, if an aggregate contains no organic impurities, it may be unsuitable for inclusion in concrete. If an aggregate contains organic impurities, it may be unsuitable for inclusion in concrete, as these may interfere with chemical reactions during hydration process. Likewise, it's often important to test an aggregate for its resistance to physical changes in its environment, such as variations in temperature. Soundness and shrinkage of an aggregate can be considerable, can have considerable effect on long-term durability of concrete that is used to produce. Used to determine properties such as resistance to impact, crushing, and abrasion, simply and accurately. Aggregates resistance to polishing can also be measured to test how it be affected by continuous contact with vehicle tire, specifically on road surface projects. Quality control and concrete. When, let me just blow it up a little. Quality control and concrete, percentage of charges. When a suitable aggregate has been selected after extensive testing, concrete that is used in also needs to be thoroughly tested, both as fresh mix and in form of hardened samples. Concrete is generally chosen for construction projects due to its combination of strength and versatility. However, with this flexibility come important issues that must also be addressed. Despite thorough knowledge of aggregate used, nature of other materials and of production processes, it is unlikely that two batches would be identical in their qualities. Mixing methods can, for example, vary from batch to batch or supplier to supplier, potentially resulting in finished precast components are required. Concrete is generally chosen for construction projects due to combination of strength and versatility. However, with this flexibility come important issues that must also be addressed. Despite thorough knowledge of aggregate used, nature of other materials, and the production processes, it is unlikely that either two batches will be identical in their qualities. Mixing methods can, for example, vary from one batch to another one, or supplier to supplier, potentially resulting in finished precast components or liquid mixes with an unacceptable level of variance. Stringent quality control. Stringent quality control processes are essential when using both fresh concrete So, stringent quality control processes are essential. Stringent quality control processes are essential when using both fresh concrete for pouring and spraying, shotcrete and precast components such as liners and lintels, as implications for inadequate quality checks can be fatal. In addition to need ensure health and safety of construction workers, there are considerable commercial and legal repercussions with potential costs associated with court action, compensation and repairs, as well as potential for negative publicity. Furthermore, life of a structure can be significantly reduced as a result of incorrect formulation or consistency in mixing. Testing concrete. These risks can be significantly minimized through sample testing using latest generation of testing technology and processes, which now form an essential part of construction project. Indeed, cost of testing is relatively small when weighed against first and cost of construction projects as a whole, and secondly, potentially unforeseen expenses caused by structural failure or premature deterioration, although many concrete testing techniques have been in existence for some time. Introduction of new technology is now making a considerable difference to spread the speed, accuracy, and consistency with which these processes can be carried out. Fresh concrete. Fresh concrete should be tested both before and during a project ongoing to assess suitability of mix for its specific application and to ensure that concrete being used is providing a consistent standard throughout. Three proven methods of testing fresh concrete at different levels of workability are slump test, flow table test, and Webby consistometer test. Slump test measures consistency of freshly mixed concrete of medium consistency and is most widely used method to assess its workability. It involves filling a conical mold with a sample of wet concrete mix, compacting sample, and then lifting cone. Slump is calculated by difference on height of mass before and after cone has been removed. Second method, flow table test, is used when there are high workability mixes with a slump of 180 mm are specified. This method determining flow index of concrete as an arithmetic mean of a third test of fresh concrete is Webby consistometer test. Hardened. Now, a third test of fresh concrete is the Webby consistometer test, which is generally used with particularly stiff mixes. This test begins with the slump test as above, in which result shall be virtually zero. Same is then subject to vibration. Vibration is a cylinder, and time taken for sample to mold itself to cylinder is measured. So this test begins with slump test as well, in which results shall be virtually zero. Sample is then subject to vibration in a cylinder, and time taken for sample to mold itself to a cylinder is measured. Longer time is seconds measured as Webby degrees, lower than workability. Hardened concrete. Sample is subject to vibration in cylinder, and time taken for sample to mold itself to cylinders measured. Longer time, seconds measures, a Webby degrees, lower workability. Hardened concrete. So you got it. What cylinder means? I can say Webby cosmic cylinder, Webby consistometer test, which generally use a particular of clay. Begins with slump test, which results with zero. Sample is in subject to vibration in cylinder, and is time taken for sample to mold itself to cylinder is measured. Longer time, seconds measured, is Webby degrees. Hardened concrete. Hardened concrete. In addition to determining suitability and consistency of a mix, In addition to determining suitability and consistency of a mix by testing fresh concrete, hardened concrete should also be tested both in laboratory and on site to ensure that component parts have desired properties and that concrete already in use has retained its qualities. Plant-produced concrete is increasingly specified by contractors, normally in the form of precast components that are manufactured under controlled conditions, offering high levels of quality and consistency. However, even in these cases, samples should be taken from site or production plant to be tested under controlled conditions to safeguard against potential variability. Density of hardened concrete can have a significant impact on its durability, strength and resistance to permeability. Density can be measured either by simple drawing, dimensional check, followed by weighing and calculations, or by weight in air water buoyancy methods. Drying, shrinkage and moisture movement. Drying, shrinkage and moisture movement. Drying, shrinkage and moisture movement can also be measured in pre-hardened concrete samples. First initial drying shrinkage test can be undertaken measuring length of molded and cured specimen. Length of molded and cured specimen under specified conditions and comparing it to its final constant length when dried. Tests can also be carried out for drying shrinkage, which is difference in length of matured specimen cut from concrete and saturated, and its final length upon being dried. Thirdly, moisture movement, where difference between a constant length of specimen when dried and its length when subsequently saturated in water is recorded. These tests determines change in length of concrete sample brought about by change in moisture content, allowing engineers to make accurate predictions of how a precast section behave when in contact with moisture. So what it actually says, as I say again, I repeat, because sometimes it's not clear. Let me say, drying, shrinkage and moisture movement can also be measured in pre-hardened concrete samples. First, initial drying shrinkage test can be undertaken, measuring length of molded and cured specimen under specified conditions and compare it to final constant length when dried. Test can also be carried out for drying shrinkage, which is difference in length of matured specimen cut from concrete and saturated and its final length upon being dried. Thirdly, moisture movement, where difference between constant length of specimen when dried and its length and subsequently saturated in water is recorded. Each of these tests determines change in length of concrete specimen sample brought about by a change in moisture content, allowing engineers to make accurate predictions of how a precast section shall behave when in contact with moisture. Compressive testing. Compressive strength testing, perhaps most important test for hardened concrete used in construction projects. However, is compressive strength testing, which allows engineers to assess the strength of concrete sample and its performance under actual loading as opposed to design loading. By testing in this way, deterioration of chemical action, weathering, fatigue, or excessive load can also be measured reliably. Perhaps most important test of hardened concrete in construction projects, however, is compressive strength testing, which allows engineers to assess the strength of the concrete sample and its performance under actual loading as opposed to design loading. By testing in this way, deterioration of chemicals, weathering, fatigue, excessive load can also be measured reliably. Latest compression testing equipment incorporating digital and microprocessor technology makes process extremely simple and accurate. This degree of closed loop microprocessor control forms invaluable elements of today's compression testing equipment, significantly increasing productivity and offering outstanding level of accuracy and consistency in testing cycle. Advanced microprocessor controlled compression testing units such as ADR auto range from ELE can be used to provide accurate and detailed results quickly. Recording and analyzing data automatically. The technology requires minimal operator involvement, allowing concrete suppliers to improve productivity, reduce cost. Combining robust construction with highly efficient operation machines are ideally. Latest machines also incorporate automatic test routines for aggregate crushing value and 10% fines value as standards, controlling loading of samples at entered pace rate until load specified in failure threshold parameter is reached, at which point load is released and peak load displayed. Pace rate and threshold values can be edited as required. So latest testing machine also incorporates automatic test routines for aggregate crushing value ACV and 10% fines value TFV. The standards controlled loading of sample at entered pace rate until load specified in failure threshold parameters is reached, at which point load is released and peak load displayed. Pace rate and threshold values can be entitled as technology is fully compliant with latest standards and specifications for concrete testing and employs specially designed upper platan ball seating arrangements to ensure there is no movement of assembly after initial contact with sample. As research has shown that any movement of upper platan coupled with frame deformations during load cycle of standard cube samples can induce tensile cracks. Oh, we can then machines use hydraulic power to provide required pressure to ram cylinder unit of load frame. At this, as this is closed loop microprocessor controlled, need for expensive control valves and problematic oil bleed type valves is removed and service life of components extended due to reduced operational stress. Testing process is largely automated. Operators need only use a simple control panel for calibration, sample selection, and test control, or to save, print, or download test data to a PC. And conclusion is latest testing equipment processes are allowing considerable improvements to be made in quality control of concrete for construction projects, allowing suppliers to provide materials that are ideally suited to their clients' individual applications. The result is stronger, more durable structures that are able to meet needs of initial design brief, thereby both increasing safety and having a positive impact on suppliers' profits by ensuring consistently successful projects and satisfy clients. And I think it's over. So we need not go back to this one now. Give me a few minutes and I will be back here for further discussion on this issue. A few minutes please. And I go and come back. चला रही है, चल रहे अपने फिर पहले भी नहीं मत सुन ये अपने नहीं, मेरा दिमाग खराब नहीं है ये तो मैंने यार बिल्कुल दफा है मैंने भी बताया कुछ नहीं है, भूल जा मैंने भी तो प्लस नहीं है पर हाँ okay, so it has conclusion and it's about 6:57, so I think we should now think of closing it. Well, I think we have gone through paper. We may like to go also. Well, I think I should save this also better. I think, is it right? I think I better save it for reference. For reference, I save it also in case some question comes. So I say concrete. I can save it better. Alright, so this is saved. I'll now close it, this paper, and we have gone through. Now this page, this I'll close this file as well. And this quality we have discussed partly today, and we have to see now. It's about just a review that we have conducted today about concrete issue, which is an important one. Concrete quality that we are concerned with, as I said in quality file. It's not easy to digest that. As I said in this file, that is get up quality, stop sleeping. This was my title. it's something different, you can say, not as usual before. Sleeping and fix quality in Bharat, India, because work quality cannot be compromised in name of fragile quality system, compliance, formality and excuse. Quality system may fail, but works quality must perform. But doesn't happen currently in entire scenario. So my direction is get up quality, stop sleeping, and you have to say this. You have to say something. And fix quality Bharat, India, that we have to do. Engineers have to do. Talk to quality, stop sleep, and fix quality in our country. And that's why it's a have active quality performing application. That is, you can say, it's kind of funny as well as sunny, both. And red lines to be resolved based on this. And we have to ask ourselves, can we bring working environment to quality requirements? If yes, how to do that? That's an important point here we have to see. And I can say, time never stops, we stop. Mind never stops, we stop. Thinking never stops, we stop. Because we are physical beings, we have some limitations, but mind, time, all these don't have any limitation. We have to be a little pragmatic in this regard. So gentlemen, my dear engineers, we have to move forward. We not to wait for others to come and tell us. We have to move ourselves. Nobody shall come to help us. We have to help ourselves. And particularly the structural engineers. If you think they are structural engineer, you have to take care of quality as well. Because don't think quality is a part of job of site people. No, don't think. It's your job as well. Yes, they have to do it, but you have also to be serious about that. Without having any degree of seriousness in designs, pertinent quality, site cannot be helped. And that's very important question we have to think about. I don't think that. We don't do our job. Just all the time talking of designs and ignoring quality. Take responsibility of quality also. Ultimately, quality starts from design itself. It doesn't start at site. At site it ends. The start of quality does its work. It has to start at site. Start at design desk, a design table, where structural engineer sits, and that engineer has to think how to achieve else you're not doing your job perfect. That's our system's effort for that. Those who intend to leave it to execution, they want to run away from their responsibility. I would take now leaving it to you people. Let's meet next time and continue this talk. And we have to cover some parts of all these titles, some parts contracts like that, and you are responsible for contract also. If you are really to help yourself and profession, and I can say with this, we have to thank ourselves. We have to thank everybody. Sometimes session goes smooth. Just as I said, certifications are indicative only, and we have to indicate them. That's indeed true. We have to indicate them, and we have to use them also. We have to indicate them as fine work, and we have to use them also as our work, and there is no way we can run away from that. So I can say gap quality, stop sleeping, gap design, stop sleeping, their job. That's where we stand now. So I take your leave, guys. See you again next time. Thank you very much.